Okay, everyone. So now let us look at equilibrium constant. So on your exam question papers, you will be asked on how to calculate equilibrium constant. You will be asked to calculate it actually, not how to. You'll be asked to calculate the equilibrium constant. So this it actually takes a lot of marks on your papers. So you must make sure you get this one right, and it's not actually a difficult thing. Then. So now let's say, for example, we have a reaction here, and then this reaction is actually, it is happening between A2 plus B2, and then it forms what? It forms 2AB. And then when time goes, this reaction, it becomes to be at equilibrium. So this A2 is a gas, and this is a gas, and then it also forms what we call a gas here. Okay, so now they say now we must calculate what the equilibrium constant. So the equilibrium constant is denoted by Kc. So from the definition or the name of this thing, it says is an equilibrium constant. So basically we're going to find this equilibrium constant when what? When our equation or our reaction is at equilibrium. So what does this equilibrium constant denote? It actually tells us to say if ever the K constant is equals to 1. It means what? It means now the concentration of the reactions of the reactants and the concentration of the products will be equivalent in the equilibrium state. Ne? But now let's say, for example, we have our Kc being less than 1. So if our Kc is less than 1, that means what? That means on our equilibrium state, the concentration of what? Of the reactants, it is more than the concentration of the products, because the concentration is less than 1. Less one is favoring the left hand side. And then now let's say what? The Kc, our equilibrium constant, is greater than 0. If our equilibrium constant is greater than 1, that means what? That means now our products are what? Are actually having more concentration than our reactants. Okay, so that is actually what this equilibrium constant is telling us. It tells us now this equal concentration of the reactants and the products at equilibrium, or the reactants are having more concentration than the products anyway, even though they are still at equilibrium, and also the product is having more of the concentration than the reactants if it's at the product. So that is what actually what the concentration equilibrium constant is telling us. So the equation of the equilibrium constant is actually what? Is a ratio of the concentration of the product, is a ratio of the concentration of the product divided by the concentration of the reactants. So every time, like I've told you before, okay, so initially the reaction does not just reach an equilibrium state. It first starts with what? With a forward or one-way reaction. So it starts with a forward reaction, and then when time goes, it reaches its equilibrium state. So every time initially we will have the reactants being on our left-hand side and our product being on our right-hand side. Even though this equation equilibrium reaction shows that we have a forward and a reverse reaction, but we know that initially we had a forward reaction, which means our reactant is on the left and then our product is on the right. So every time you will know that your product is going to be on your right and your reactants will be on your left. Okay, so it doesn't matter what does the Chatelier's principle is saying, which reaction is favored. We just calculate the concentration, equilibrium concentration, we just look at what the reaction, what it says. The reactions, the reactants are this one, and then the product is that one. Okay. So now let me just make a typical example that they're gonna ask you, like when you are on exam. They will just say, okay, initially we give you what? We give you 4 moles of A. So these 4 moles of A, they are reacting with how much? With, let's say for example, 7 moles of B. They react with 7 moles of B, so that they form AB. Né? Okay, and then now the statement comes and say now, okay, so now when these things are forming the at equilibrium, we are only left with how much? With, let's say for example, we are left with only 3 moles of the product, which is AB. So we have 3 moles of AB. This one is for A, and then this one is for B. Okay, but this one here is at equilibrium. This one there is at equilibrium. Okay, so when we solve these K constant problems, we must draw what? We must draw what? Our K constant table. I know you know this table. So on this table here, we'll have what? We'll have our reactants. That means elements that are reacting. And then we'll also have what we call initial moles. So initial number of moles. And then we will have change in moles. We will have change in moles. And then we also have the number of moles at equilibrium. And then we'll have, lastly, we'll have the concentration. So remember, we want to calculate the concentration because our equilibrium constant is a ratio of the concentration of the product divided by the concentration of the reactant. So now here we'll have what? We'll have our reaction having 2A2 and then B2 forming what? 2AB. Okay, so pay attention here. If ever what? If ever on your reaction you have a solid or a liquid, that means you don't have to include a solid and a liquid on your table here. On your equilibrium constant, the liquid and the solid, you don't include them. You deal with aqueous and gases. I will just make one example of that after this one here. So let's say for example we have initially we had how many number of moles? We have 4 moles of what? Of A2, and then we have it was reacting with 7 moles of B. Okay, so now, but initially when the reaction start, we only have the reactants. We don't have a product. So the product will assume that the product is 0, because when the reaction starts, you only start with reactants without the product. So now the statement says now, okay, so when our reaction is at equilibrium, it means now when our reaction is at equilibrium, we are having what? 3 moles of AB. So that means 3 moles of AB is produced now when the system is at equilibrium. So we say now at equilibrium we have how much? We have 3 moles of AB that is produced. Okay? Okay. So now we'll come here to the change in moles. Change in moles, we'll say now, okay, what happened? Because initially we had 0. How did we get to 3? That means we have added what? We have added 3 moles to the product so that we can form this one. Okay, so when we have one change here, we can do what? We can actually use stoichiometry to get the one here. Okay, so because now this one is a ratio of 2:1, that means 2 moles of this one are produced. It's gonna be produced by 1 mole of B and 1 mole of A. So now that means when we get the number of moles, changes moles here that were used for B is gonna be what? Is gonna be 3 divided by 2, which is going to be negative 1.5, because remember here on the reactants, these are the moles that are used to form this one. This is plus 3 is because it gained 3 moles during the products. And then when you use the ratio of your stoichiometry here, if it's 3 moles here and then it's 2, that means it's going to be 3 is going to be 2 times that one of A here. So that means the one of A, it will also use up negative 1.5. Okay, I hope that makes sense. I hope it makes sense. So you use stoichiometric ratios. If you have 3 moles of this one here, when you use your stoichiometric ratio, it means, okay, this is going to be 1:2. And then you will just say, okay, I have 2, and then I have 3 for 2, and then you have x. You will calculate the value of that one is going to be 1.5. You can use it that way, but just that I know that this is the ratio of B is going to be the ratio of AB is going to be 2 times the ratio of B. So now if it's 3, that means B, it has to be half of 3, which is going to be negative 1.5, because it is used. So the negative side, it means what? It means this what? There's a number of moles that were used to form what? To form the product. So now when you put that on your calculator, you will have 4 minus 2.1, negative 1.5 is going to be what? Is going to be 2.5. And then also here when you minus, you have 5.5. And remember now they must give you the question. In the question they must give you what? The volume. They say now your system is operating under the volume of how much? 2 decimeter cubed. So you will just use your concentration equation so that you can calculate your what? Your concentration of your reactants and the product. So your concentration equation is actually C is equals to N over V. So we have number of moles at what? At equilibrium. Remember this what? Is an equilibrium constant. So basically we want the concentration of what? Of equilibrium. Yeah? So we are looking at equilibrium here. We have number of moles at equilibrium. We say number of moles at equilibrium is going to be, for A is going to be 2.5 divided by 2. And then you will get for B is going to be how much? It's going to be 5.5 divided by 2. And then you get for AB, which is going to be what? 3 over 2. Okay? And then now when you have all your thing in there, let me just use it. Okay, so that means our 2.5 divided by 2, we're going to get our answer as 1,5, and that is a concentration of A. And then 5.5 divided by 2 is going to be how much? Let's check. 5.5 is going to be 2.75, 2.75. And then you write the SI unit of concentration there. And then here is going to be 1.5. Okay. Okay, so now I'm just gonna do what? I'm just gonna calculate my Kc value. Okay, so remember my Kc value. My Kc value, it will be equivalent to what? To my product, concentration of my product. So concentration of my product, concentration of what? Of AB is my product. So what is the concentration of AB? Is equals to 1.5. Remember, so it's gonna be 1.5. And then I look at the coefficient there. The coefficient, if it's 2, I just square my concentration. And then I go down there, and then the concentration of A is going to be 1.25. And then I will multiply it with the concentration of B because it's the reactant. So it's going to be 2.75. And then I will get my concentration equilibrium constant as let me check. Here is 1.5 squared, all divided by 1.25 multiplied by 2.75, which gives us a 0.65. So if it's less than 1, that means what? That means more reactants, the concentration of reactants will be more at the equilibrium. Thank you very much. I hope it makes sense. I'm already tired here, but I'm trying to push. So thank you.